The next presentation is from an important partner for AVEVA and our electrical engineering philosophy that goes from cable and equipment design to cable routing and accurate material control. Okay, so then I have this one. ETAP is well known for its world-class, reliable load flow analysis solutions. And many of you already use their solutions as well as you use our solutions. Many common customers on this slide. So what we have done now is to bring these two applications together into a formal partnership that was signed in May this year. And for those who know, Dave Gibson was involved a lot in that, in making this happen. He was really our evangelist on the project for many years. And this provides, this interface, this partnership, will provide a complete round-tripping with data entry only once, securing in the knowledge to provide safe operations. The benefits of being able to bring electrical engineering design change back to the ETAP provided analysis for plant is significant for the certification of projects, and in particular nuclear operations. The working analysis of this common project between the two companies and their applications has taken over 2 years. We had to travel back and forth many times, but the fact joining the teams, the product development and strategy teams of both companies together proved really beneficial, making this, as we hope, really a good success. It's available soon. So, yeah. And probably if Dave were here to present this piece, he will probably talk about some late-night meetings discussing load analysis with Shervin and Farouk, owners of the ETAP company overlooking the Pacific Ocean. And actually what I want to say with this, it's about the passion of people within their domain. And that is the start of the relationship between AVEVA and ETAP that goes back to 2008. And for those of you that were here, well, not here, but in Boston last year, you might have seen already, ETAP was an exhibitor partner in the AVEVA World Summit. So this year, we'll have a presentation. We have, since our partnership, decided to involve both companies in some more regional events. So we've had a experience first time, and I see Cedric here in the front. He was participating in our French event earlier this year in June. The feedback from our customers was really positive. So we have decided to extend this experience to further regional events. So you might see both ETAP and AVEVA in some other regional events later in the year. But for now, enough of me. I have the pleasure to welcome, to introduce ETAP's Chief Operating Officer, Shervin Shokooh. Welcome.
Good afternoon, everyone. How's everybody doing? I'd like to thank AVEVA for having us here. It's a pleasure to be among you. There was a lot of interesting and informative sessions this morning. So I thought maybe my conversation to you should be about what is the overall concept of what we're trying to do with AVEVA, which, as the title suggests, why model-based engineering or model-driven engineering solution and predictive analysis are essential to both design and the operation of any system. So kind of an overview, what we're trying to achieve in any design, in order to understand the design and the operation of any facility, one first must understand its behavior. And in order to understand the behavior of any system, you have to have the means and the tools to analyze and identify what is to happen in the system to prevent issues and problems early on in the life cycle. And you're all in the same business of either engineering a solution or operating a facility, so you can understand that identifying those problems by improving the design also helps avoid future problems in the future, in the distance. And preserving the lifespan of the system is ultimately the goal of the owner-operator. So providing efficient and actionable actions to those owners and operators ultimately increases the savings of a facility. So prediction, what we call a predictive or prediction models, are really have been shaping our experiences over the years. And even today, you got the Google and Amazon, they sort of tell you what you should expect to have, what you're thinking, or anticipating your actions. And this is the same concept that has been provided with these sort of predictive models in the engineering world. So they really recommend products and services based on our habits that are collected from this connectivity platform, which are between devices, software, systems, that are making this complex data, what is known as big data, available to us. So there's a variety of information at high volume, high velocity. And again, big data to us is nothing new, right? In the engineering world, we deal with all sorts of data, from equipment data, cable data, for pump, structural. All that information has to come together in a comprehensive and understandable form for you to make decisions. So really, the expectation of the market has been to have a total engineering solution where you design, model, analyze, validate, and then take that system online, hand it over as part of the handoff to the owner-operator to be able to make informed decisions. So this is really a predictive analytics tools that ETAP offers, and on top of, say, the AVEVA platform. So the utilization of big data, or this complex set of data that we have, by simulation models is really, and the real-time analytics is really providing a paradigm for engineers and operators. And it's been doing that for the past probably 20 years, but more so probably in the past decade, where they can take actionable information and decision-making support systems as part of that model that, again, goes from design all the way to operation. You heard about cloud applications that was discussed earlier today. So providing these connectivity platforms, this efficient way of exchange of information is key to making these predictive actions and analytics happen. So really the essence or the baseline for it is proactive action rather than simple reaction. It's the name of the game. So this model-driven engineering platform, they serve as a centralized executable specification during the system under development, which at the same time, when the system is taken online and given to the owner-operator, they provide additional insight to operation. So this is sort of the bridge between the offline, or what we call the design world, and the operation world. And ultimately, you're optimizing and improving the efficiencies and providing business intelligence. Now, in the electrical world where I'm from, really the one-line diagram with the schematics, or the 2D, provides and the model behind it with all the attributes acts as a virtual blueprint of the system. And this virtual blueprint could consist of network topology, electrical parameters, non-electrical parameters, other pertinent information, could be operational information. But once tied to time-synchronized data through a SCADA system, through any sort of metering information, it provides that insight. Then on top of it, when you add the graphical presentations, give you those accurate visualizations. So that's really the concept of predictive modeling analysis in the form of an engineering tool. So sort of the building blocks, if you may, of the situational assessment. I mean, this is nothing that all of you probably have learned this sometime or another, even in school or you learned it the hard way. You bring the complex data, or a set of data that you have, and you plug it into this model or detailed model of a system. And it could be electrical, mechanical, structural. And you take that information and put it into a situational awareness box, which is really a perception and a comprehension of the system, which really the next step is where the decision, the intelligence, the magic happens, right? The predictive analysis, and it could be from in our business doing things like power analysis or expectation of what the stability of the system is. If you have a generator that fails and goes offline, what would happen to the system, how the system recovers, and ultimately making that decision to give the designer, the engineer, or the operator the performance, the action, to the means to be able to make those decisions. So again, from stimulus to response. So the intelligent situational awareness is really providing these prediction models to increase the efficiency and the provide a repeatable environment for designers, engineers, operators to test what-ifs, to find out how they should improve the system, design, again, and operation, having that intelligent situational awareness. Now, again, we ask, why should you have this? Well, this is a reason why you should. Lack of intelligent situational awareness could be very costly. You're being able to understand and predict, anticipate what to happen to prevent issues to happen. I just found that picture quite interesting. Couldn't get any high-resolution version of it, and it would have been interesting if it was a video, actually, to see what will come after the truck would go under the bridge. So today, actually, you heard about the life cycle in 2 or 3 presentations. And this life cycle, although it's a part of the digital asset, right, goes from the design all the way to in-service or maintenance, this situational awareness has to exist, again, has to exist in all phases of this phase of life cycle of a plant, from inception all the way to in-service. And why? Well, the reason it needs to exist is to provide you the tools to do root cause analysis, to identify the operating problems, design problems, again, before they happen. The what-if analysis is key because you could take alternative action. You're doing a design of a system, and if you, for example, in electrical network, if you size a cable, and you want to see, well, what it would be if I reduce the cable. So you can do optimization on the size. But there's so many other parameters that you might do a number of what-if analysis. And if you could take that information, and if it was existing a brownfield plant, and you could bring historical data from the field, plug it into that model, and see what actually happens in the system, it would give you so much more insight to better design and operate the system. If it's a greenfield project, once the system goes online, you can validate your design before even actually committing to it. So it serves as a learning tool as well. It means to be able to predict what happens. As an example, many of you, I'm sure you work in process industry, so take a refinery, take any process plant, and an operator who's actually has this model, a model-driven engineering solution, which is part of his day-to-day power management or system management program. He is starting a 10,000 horsepower compressor. Now, this 10,000 horsepower compressor doesn't run every day, it doesn't start every day, it's online and producing. So for this operator to see what will happen if everything was running while this compressor was off, and he wants to virtually simulate the operation or the start of this compressor, he could just take a snapshot of the system, get the exact level of generation, loading, the topology of the system, the statuses of the breakers, the switches, whatever is in the system, and be able to start that compressor to find out if there's going to be an issue in the system, there's going to be an under voltage in the system, a brownout, and then he can take that action once he's validated his action using a real-time model, which is connected to the metering equipment. And that's really intelligent situational awareness on the operation side. Same thing goes again for the designer and the modeling stage, to be able to have that knowledge of the system and do what-if analysis in a repeatable environment to find out the root cause analysis of potential design flaws. So this anticipation of problems and design, it's really what we coined this phrase, faster in real time, trademarked it, and it's the steps beyond analysis and simulation where big data, again, this complex data, meets analytics to provide actionable information and predictive behavior. So a quick concept of what ETAP does. So we're a power system analysis and operation software platform. And we offer tools for design, and again, as I mentioned, on the energy power management, from low voltage systems to generation, and they're actually controlling it from the back, to transportation, for designing vessels, ships, airplanes, to distribution system, the smart cities and the smart grid of today and future. That's for operation, again, design and operation. Transmission, and of course, industrial facilities, which is very close to our business because that's where we started at, actually. Again, going back to the life cycle of the system, so what we do as part of this digital asset world, as model-driven world, so we start with the design. the intelligent modeling, the schematics, the one-line diagram, the geospatial layouts. And you add on the analysis tools. In our business, again, it goes from power flow studies all the way to dynamic stability studies to much more complex analysis that you may or may not do on a daily basis. Protection coordination, this is for safety. Arc flash hazard, I'm sure some of you hear that all the time from your engineers, arc flash requirements. So you do the design and you move it to the construction phase, and this is where you would use revisioning. So you do as built and as found and use these tools to be able to do, what if I do this? What if I would change it to a different condition before you commit to the as builts? Then you have the commissioning phase where you, in fact, this is where you take that model of the electrical network with all the attributes behind it that is communicating with AVEVA Electric, for example, and you validate that model before you hand that model off to the owner-operator for operation. And that's where the magic happens again. You got decision-making tools for prediction, automatic generation controls, load shedding, economic dispatch, substation automation. All those tools are now at your fingertips. Again, what the intelligence that is provided to you is that model. And ultimately, you go to in-service, which is, again, the part of the digital asset lifecycle management. So let's say you have a system online and you're planning to add a new process unit. You're adding a new section, a new phase to the project. You take a snapshot of the online model with all the validated parameters that is already online because it's operational. It has to be validated. And you take that model, you add your new section to the model, you go through the whole cycle again, back to operation. And this enforces validation and having an exact model as been built. And this, again, this is not a new concept. This concept has existed, but it's been more and more picked up by a lot of the owner-operators. In fact, it's been demanded by a lot of the owner-operators. In fact, we should be in the other room talking to them more, perhaps, about the need for this. As an example, this is a project that was done maybe about a couple of years ago with a collaboration with one of the engineering firms. It's a mining plant in Papua New Guinea, a gold mine. And they had very unique problems, but not so much unique to any mining field, where they had, as far as the size of the system goes, about 120 megawatts of generation, 20 megawatts of geothermal, the rest were diesel fuel, and they had 5 interconnected power networks together. This is sort of an overview of it. So not a complex system, but nonetheless quite involved. So the big issue for this client was reducing costs, produce more. Who doesn't have that issue? But in fact, one of the biggest problems was that they had $140 million, more than $140 million worth of diesel fuel that they were using on a yearly basis. And their spinning reserve was high, and not to mention the reliability of the system was low. And so the 3 main objectives actually started from, again, existing system, that they needed some safety improvements because of short circuit problems, arc flash problems, safety issues. Also this improving the stability of the system and reducing the cost. So the model-driven concept really started from this system model that they had an existing model, but it was not validated. So they had to put the data in. They brought the data from various sources, from your CAD drawings, from existing operational parameters, support maintenance, build the electrical model and enhance the electrical model, integrate it into a common database, then take that information to the design and analysis phase. In this particular project, the emphasis was given on 2 types of studies. Again, arc flash studies and stability studies, because those were their main issues, and cost and optimization. And then that system was taken on operation for system stability, maximizing load preservation, and critical process operation optimization. So part of this design migration from offline to real-time was actually quite interesting. So they had the model of this is one of the generation plants. So knowing that they're going to go online, they started adding the metering equipment as part of the electrical assets to the system. So every location would get the electrical meters, which ultimately would connect to the actual meters in the field. And so that was one of the processes during the design phase of the project, working with the electrical instrumentation control team. And ultimately, once the system was designed, so they've done the arc flash studies, they got their OSHA requirements, compliance in place. But in fact, from the operational point of view, During the design and analysis phase, they immediately find out by saving 1% on the fuel cost, they would have paid for the project right away, immediately. So in fact, what happened was once the system was online, because we had a model in place that could actually predict the system behavior, they were saving 10% on fuel cost. Significant amount of savings. And reducing reserve, spinning reserve was part of it, because now they're using less of the generation that they don't really were utilizing. And at the same time, the system stability was improved. So a real case, they have tools for situational awareness, graphical, 2D, 3D tools. They had dashboards for KPI, business intelligence, to know where the system is, so they could monitor and operate the system on an ongoing basis. So simple views for managers and engineers, while the analytics behind it was quite complex. So in summary, what intelligent situational awareness is giving us is utilizing these models to reshape the operating model from design to operation, providing this new computing platform for big data to ultimately do this type of analysis. And this is not a one-company game, and hence why Julian started with the discussion. This collaboration between ETAP and AVEVA Electric, it just doesn't stop at the design stage. We really have this multi-vendor approach where you take the data from either ETAP model or a AVEVA Electric functional design, and you take the data through a whole round trip. So you validate the design by the AVEVA Electric and ETAP. You provide the intelligence during the design and the commissioning phase, and ultimately pass that handoff to the end user. So we're quite excited about this. We hear a lot of good stuff about AVEVA Electric. I personally haven't used it, but for all the customers that I've talked to over the couple of years, they're very excited about this collaboration and integration. So to conclude, just to wrap up the concept, model-driven platforms, such as ETAP and AVEVA, are really shaping the future for any operation and design concept when they come together. And we talk about this handoff, so this is a key component of that. Providing means to accurately and reliably model and predict the behavior ultimately runs into reducing CapEx and OpEx and total cost of ownership for the user. And again, the one connected platform is really what is important. So the integration of these tools and the solid integration of these tools are key. So we have a lot of design discussions to make sure, look, this has to be seamless when you go from one platform to the other, so the experience is there. So with that, I'd like to thank you again, and hopefully this was informative. Thank you.